Hello and welcome back to another video. In this problem, we're going to be continuing on with the TypeScript line 75, and we're going to be doing longest consecutive sequence. So in this problem, you're given an unsorted array of nums, and you want to return the length of the longest consecutive element sequence, and they have to be actually increasing, so every single element has to exist. So you have to have like 1, 2, 3, 4, but 3, 4, 5, 6, you can't have anything missing. So in this first example, we're given 100, 4, 200, 1, 3, 2. So the longest sequence is 1, 2, 3, 4, which was length 4. And in the second example, we have two zeros, but the longest sequence is 0, 1, 2, 3, 4, 5, 6, 7, 8. So we need to figure out how to do this in O of n time. And I'm going to show you a trick to do this. So any problem where you were asked to get the longest consecutive sequence or some kind of sequence that needs to have every single number, can't have anything missing, what you're going to want to do is you're going to have a set. And so you take these numbers, you put them in a set, and let's just show an example here. So let's say we have 100, we have 4, we have 200, we have 1, 3, 2. And now it's pretty straightforward. All we want to do is recognize that the longest consecutive sequence, the element that starts that sequence, will not have a preceding element in our set. So for example, if the longest sequence is 1, 2, 3, 4, then 0 cannot be in our set, right? Because if 0 was in our set, then we would have 0, 1, 2, 3, 4. So the element that starts the longest consecutive sequence, or just a sequence altogether, the efficient elements to pick are the ones that the previous element is not in our set. So this is going to be pretty straightforward. We're just going to loop through everything in our set. So we're going to say, okay, like for 100, is 100 minus 1 in our set? No, it's not. So that's a valid start of a sequence that we're going to want to check. So 100 is in our set. Okay, well, that's length 1. Is 101 in our set? No, it's not. So this is length 1. Then for 4, we're going to check, okay, is 4 minus 1 in our set? Yes, it is. So we're never going to want to use 4 as the start of a sequence, right? Because we can just use 3, and that's always going to be more efficient. Any sequence with 4 is going to have 3 in it, and that's going to be a longer sequence automatically. 200, there's nothing below 200. There's no 199, so we would check that. So we would say, okay, we want 200. Do we have 201? No, so the sequence is length 1, just like the result here. And then for 1, is 0 in here? No, it's not. So then we have to check what's the longest sequence using 1. So we have 1, we have 2, we have 3, and we have 4. So that's length 4. Then for 3, 2 is in our set, so we don't want to use that. And for 2, 1 is in our set. And if you do this, you will have an n-time solution because you will only, when you're actually looping through your sequences, you will only use each element once because you will only start the sequences with the first element in that sequence, right? So in 1, 2, 3, 4, we are only going to loop starting at 1. We're not going to loop starting at any of these because the previous element is in our sequence. That's kind of the trick you need to do. And let's actually look at that for this second example, and then we can code it. So we're going to have 0, 3, 7, 2, 5, 8, 4, 6, 0, 1. And you can optimize it a little bit, I guess, right? So like, because we're going to look at sequences starting at 0 twice. Actually, no, we're not, because this is going to be a set, right? So we're not going to look through it twice. So when we turn this into a set, this will go away, right? Because we'll only have 1 of each element. So when that goes away, we're going to check for 0. Okay, is negative 1 in our sequence? No. So then we're going to look at the sequence starting at 0. So we're going to say, okay, 0 is in here. That's 1. 1, 2, 3, 4, 5, 6, 7, 8. That's a sequence of 9 elements. And then for everything else, the previous element is in our set. So for 3, 2 is in our set, so we don't want to do anything there. 6 is in our set, 1 is in our set, 4 is in our set, 7 is in our set, 3 is in our set, 5 is in our set, and 0 is in our set. So our answer would be 9. And that's pretty much how you do it. You make a set, and then for every number that doesn't have anything before it, you would calculate the length of that sequence. So now we can actually code it. I actually do have a solution here, but we're going to recode it. So what we're going to do is we're going to write const uniques, which is a set. So we want to make a set. We want to put our numbers into the set, so that will get rid of all duplicates. Then we have a result. And then we simply want to loop through our set, right? So for let num of uniques, we want to loop through them, and we want to check, is num minus 1 in our set? So if uniques has num minus 1, we're just going to continue because we're never going to want to use that number as a start of our set because the num minus 1, once we get to that, that's going to be a more efficient solution. So if number minus 1 is in there, we just continue. Otherwise, we're going to say let's let the count be 0, and let's loop from this number until there are no more numbers. So we can just say, well, uniques has num. We're going to keep looping through it, and we're going to increment the count. And we are going to increment the number until the number is no longer in our set. Then finally, the count is going to be the length of that sequence that started with whatever number we used. And then we can simply say result equals math.max of result and count, right? To get if this current count is bigger than the result, let's update the result. And finally, let's return the result. And let's try to run that. Okay. And let's submit. And there you go. So it's accepted and it's very efficient. So let's look at the time and space here. So like I said, for the time, we are looping through every number in the set, which is O of n. And then for every number, we are only starting sequences from numbers that are the first number in the sequence. So essentially, realistically, this will be like O of 2n, because what would happen is you would loop through every number still, but for every number that started the sequence, you would loop through those higher numbers. So you are going to hit some numbers multiple times, but you should only hit them twice, which is fine, right? It's still O of n. So for the space, then, we use the set, so that's O of n as well. And we use the result, which is nothing, but yeah, essentially because we use the set, that's O of n. And yeah, for these problems, literally, if you need to have exact numbers, use the set. But if this were reworded to like the longest increasing sequence or something where you can skip numbers, so like if 1, 3, 4 was a solution, then you would have to use something like DP, and this wouldn't work. But because you know the exact numbers you're looking for, anytime you have something like that, you can just check a set, and you can just check like, hey, is the number I'm looking for in my set? If yes, do something. If no, do something, and so on. So a set is a lot more useful than DP. You could obviously do this with DP as well. It would just not be O of n time. Okay, but yeah, that's going to be it for this problem. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.